Hello everyone, here we are again. Today is all about ozone, and so really our objective is to take a look at why is it beneficial, why is it detrimental, what creates it, what destroys it, and there tends to be a lot of confusion around ozone for a good reason in my opinion. It's a little complicated. I've got this first slide that has a thing about the Montreal Protocol, which is pretty cool. It happened about 30 years ago once we discovered that ozone, things can destroy the ozone, and it's just an example of a worldwide treaty that works. Unlike some of the other ones related to environmental issues like Kyoto Protocol and climate change issues and things like that. Here we go. The big question is so what is the deal with ozone? Why is it good? Why is it bad? And really the answer to that is it depends on where the ozone is. And so I'm going to pop over here, and ozone, by the way, is O3, 3 oxygens. I'm going to pop over here and let's just take a look at our atmosphere. And so we've got a few layers here, and there's one more, exosphere. We're not so concerned about these layers. We're concerned about these two, in the troposphere and the stratosphere. And so I've got an expression for you to remember: good up high, bad nearby. We're going to focus on bad nearby here for part one. And so that's down here in the troposphere. That ozone is harmful. The way you can remember troposphere is because tropo, TR, is where the trees grow. That's where we are. Our experience of life is in the troposphere for the most part. But it can cause pollution, right? So that's what ozone is down here, and it's a complicated reaction. It's also called, ozone is called photochemical smog, and I think most of us have seen that at some point. Photo means sunlight, chemical means, there's some nasty stuff in it. And so really here's how it works. Nitrogen is a piece of it, and nitrogen, as you know, is mostly in the air as N2 with this triple bond. Only bacteria can break that for living things, or lightning or something else that's hot can break that apart so it can oxidize. Something hot like the combustion in a car, an engine, or a tailpipe, or a coal burning power plant, something like that. So that N2, that nitrogen is broken apart, reacts with oxygen in the air to create NO2, which later can react with carbon monoxide or oxygen to create O3. That's the simplified version. And then nitrogen dioxide mixes in with it to kind of give it that brownish, yucky look. Here it is again. I was looking on the internet, and it's just like lots of complicated reactions. I wrote this myself to hopefully simplify it. So you got N2 plus O2 turning into 2NO. That can react with O2 to make 2 nitrogen dioxides, which can then get broken apart. HV is high intensity ultraviolet radiation. So zap it with some energy, it can come apart again, and now that oxygen that's free there can combine with O2 to make O3. And then it can further react with NO to go back to NO2 and O2. And so it's just like this whole soupy mess. Also down here, VOCs, volatile organic carbons, are also in this chemical soup, and those are little particles that come out of your tailpipe, this organic, unburned, nasty things coming out of the fuel. And so that's how it works. One thing to notice is I put in here secondary pollutant. That means it's not formed at the source. So things directly coming out of the tailpipe are primary pollutants, but this has got to go through a whole series of reactions, and so they call it a secondary pollutant. Write that down, it's important. So back to our Cornell notes here. O3 is a secondary pollutant, photochemical smog, most abundant air pollutant in the US. We just talked about why it forms. Where is it? Well, there's some in the Bay Area, as I'm sure some of you have noticed. It's also in Los Angeles, Smell A. You can see it on a clear day, as they say. I'm going to guess this picture might be a little bit dated, though, because that looks really gross. And to LA's credit, they're doing a lot to clean up their air, and they still have some work to do. My first experience with smog was down in Santiago, Chile, where I'd been traveling through South America, and I finally got to where I thought I was going, and this is what I saw. Yuck. It was my first experience with it. Nasty, makes your eyes sting. And so why LA? Why Santiago? Both of them have mountains, as you can see. and big cities with lots of people driving cars and that kind of thing. Denver, and they're both by the ocean, but that's not important. Denver, Colorado also has smog. What's important is this basin. So you get the mountains there, because one of the things that sets up the photochemical smog is something called a temperature inversion or thermal inversion. I would definitely write this down because it's important. And so normally what we have is sun heats the earth heats the air, hot air rises through convection, and as it goes away, it gets cooler, right? That's normal. What happens in a thermal inversion, I'm going to use this picture here, is picture that sun coming up in the morning and it's heating the ground over here and the air is getting warmer. Maybe it's heating the side of this mountain and the air is getting warmer, but it's still casting a shadow down here in this basin. And so you got cold ground keeping that air right on top of it cold. And then maybe some of this warm air blows across, but what the result is you've got a layer of warm air on top of cold air. That's why they call it an inversion. It flips and it traps that cold air down there and any pollution that's in it. And so that's why you get this, that smog can't get out of there. There's a thermal inversion going on. But eventually, nighttime comes and the thermal inversion goes away and all that smog can blow out. And so there it is, the quick and the nasty, literally, on smog. Consequences can cause lots of respiratory problems, asthma, things like that. It doesn't look very nice, so you got the aesthetic piece of it. It just looks and smells gross and makes your eyes hurt. And then also you could probably make an argument that it interferes with photosynthesis too, so it's blocking sunlight coming through. So there it is, part one, quick and nasty. Come back for part two. We're going to focus on the ozone layer, equally as important as smog. Okay, thanks for staying with me.